So we're going to find some of those zeros, some of that multiplicity. We are going to start with f of x is equal to an x to the third minus 5x squared minus 16x plus 80. Now, what we want to do is we want to set this equal to 0. We want to factor it. We want to find the zeros. As you notice, I've got 4 terms here. I can't put this into the quadratic formula to solve because I've got an x to the third. Quadratic formula only works wherever I have the largest exponent being a 2. So what I'm going to do actually is I'm going to do a procedure that some of you may recognize. It's called factor by grouping. Whenever I have 4 terms, I can factor by grouping. And so what I'm going to do is I'm going to look at these first 2 terms, and I'm going to group them together, and then I'll group the second 2 terms. I do not add parentheses around anything. I'm just grouping those 2 terms together to look at what I can factor out of each of those terms in that group. Now, looking at these 2 terms, I'm going to take the greatest common factor, so I'm looking for the GCF of each group. And so the greatest common factor of this group is going to be an x squared. So I'm going to factor out an x squared from this first group. And when I do so, that's going to leave me with an x minus 5. Then I'm going to look at what I can factor out of the second group. I look for the largest number that I can take out. Well, I'm going to give you a hint. You want what is left over to look just like this right here, to be this x minus 5. Okay? So you want it to be this same thing. So if you want this to turn into just an x, try factoring out a negative 16. Does 80 divide by 16? Well, yes, it does. So I'm going to factor out a negative 16, and when I do, I'm going to be left with a positive x, because negative divided by negative gives me positive, and then positive 80 divided by a negative 16 will give me a negative 5. Now notice, these 2 things are exactly the same. And I want that because now, notice, if I, again, group my terms, this term compared to this term, what is common between these 2 terms? Well, the thing that's common between these 2 terms is this factor of an x minus 5. So I'm going to factor out an x minus 5 from both of these terms, and I will be left with that x squared minus 16. Now, I can actually factor this x squared minus 16. This is what is called a difference of squares. And that difference of squares, basically I look at the square root of x squared and the square root of 16. And I will have an x minus 4 and an x plus 4. And then I'll still have this x minus 5. Now we have this polynomial is now in factored format. if I were to multiply this back together, I would get my original function. What we would do now to get our zeros, we would set x minus 5 equal to 0, x minus 4 equal to 0, and x plus 4 equal to 0. That would give me that x is equal to 5, x is equal to 4, and x is equal to negative 4. Each one has a multiplicity of 1. Now, I want to make some connections here. Go back to my very top. What is the degree of my polynomial? The degree of this polynomial is a 3. What is the total multiplicity? So in other words, add up all your multiplicities. It should be the exact same values. Your total degree and your total multiplicity, they will add up. So whenever you're looking for those zeros, and we're going to go over another one, let's look at if we have g of x is equal to a negative x to the 4th plus x to the 3rd plus 2x squared. Now this one's a little bit more straightforward. Look for your greatest common factor. Notice each one of these has an x squared. And I'm going to go ahead and tell you, take out that negative. Go ahead and take out that negative to make that leading coefficient inside a positive. So if I do this, I'll take out a negative x squared. That's going to leave me with a positive x squared minus x minus 2. Oh, this looks much more familiar. And if you need to, you can go off to the side. And notice I said go off to the side. Negative 2, things that multiply to give me negative 2, that will add to give me a negative 1. Well, that's going to be a negative 2 and a positive 1. So that's going to be x minus 2, x plus 1. And then I still have that negative x squared sitting there. So then I set each of my factors equal to 0. So I have a negative x squared equal to 0, x minus 2 equal to 0, and an x plus 1 equal to 0. So this will give me x equals 0 because I divide by a negative and then take the square root and I still get x equals 0. This will give me x is equal to a positive 2, x is equal to a negative 1. Well, my x equals to a negative, x equals to a 0 actually has a multiplicity of a 2. X equal to 2 has a multiplicity of a 1. And x equal to a negative 1 has a multiplicity of a 1. So I have a total multiplicity of 2, 3, 4. And the degree of my polynomial was a 4. And in the next video, we're going to discuss what happens with these multiplicities.